Today's video is about the abstract factory design pattern. Hello, I'm James Helfrich. There are several different design patterns which help us to create objects, one of which is the abstract factory, and it can be a bit difficult to understand, but here's the gist of it. If you have several different categories of objects you want to create, the abstract factory will simplify that process. Today's video will define the abstract factory and explain how to implement it in your code. First, let's start with the definition of the abstract factory. An abstract factory is a collection of factory classes, each customized to the specific needs of the client. So let's say I want to create a Porsche 911. So I'm going to have, of course, a Porsche 911 factory. The abstract factory design pattern actually has no attributes, which begs the question, why do we use a class? And the answer is, well, we can't really do inheritance with just functions. We can only do inheritance with classes. It'd be great if we had a programming language which allowed us to inherit functions. Now, we're going to have a factory method. And notice how this factory method is a pure virtual function. And this means the factory class itself is abstract, and that's where we get the name from. It's because it's an abstract class. Now, because it's a pure virtual function, I'm going to have a derived class, in which case I'll have a California, a England, and a France derived class. Now notice that every Porsche sent to California needs to adhere to the California's rules and regulations. And the same is true with England, and the same is true with France. And each of these different locations have different requirements. And so to make sure that all the cars that are going to California meet the California requirements, and the same with England and the same with France, I'm going to have a different factory for each of these three different locales. Now, we have no attributes for any of these, but we will have a factory method customized to California, customized to England, and customized to France. Now, this is the gist of the abstract factory design pattern. Now, I often have a helper function, and this is a protected method called factory, and it takes a config. And this config is going to specify, in this case, whether I have a left-hand side or a right-hand side drive, which side the steering wheel it goes on, my level of emissions, which is going to vary from country to country and locale to locale. And the same thing is true with my level of safety standards. This includes the bumpers and things like that and airbags. Now, how are we going to implement this? Well, I'm going to have a California factory, and it's going to take the model. And now I know that all California cars are going to have a left-hand side and high level emissions and a medium level of safety. And from here, I'm going to call that protected method that's going to have that particular config. So no matter what model of Porsche 911 I create, whether it's a Targa or a Carrera or a GT2 RS or anything like that, every one of them is going to be left-hand side, high emissions, and medium safety. And the abstract factory allows us to guarantee that. Let's take a look at another example here. Here I have a chess game that has several different types of pieces: the king, the queen, the rook, the knight, the bishop, and the pawn, and they're either black or white. And I want to know what's the best way to create objects for this chess game. I could create a factory method, and this allows the client to specify whether they want a knight or a bishop or a rook or whatever. But I also always have to specify what color it is, white or black. And so maybe I can come up with an abstract factory for this. So I'm going to start with my piece. And of course, my piece is going to be a king, a queen, a rook, and a bunch of other different piece types. We get that. Now, I like to create a piece factory. Now, one thing I can do is I can create a black piece factory, and the black piece factory will create a king or a queen or a rook or the other different types of pieces. And then, of course, I can also create a white piece factory. And since the factory method in the piece factory class is abstract, this is the abstract factory design pattern. Now let's take a look at the pseudocode for this. I'm going to have the white piece factory, and it's going to have a factory method, and it's going to take a piece type. And I'm going to say, what type of piece am I? And if I'm a queen's rook, then I'm going to create a new rook at spot 0, 0, and white. And notice how that because it's a white piece factory, I know that it's going to be on the 0 rank, and I know that the piece is going to be white. And so I can make the object creation process much simpler. And then if I want the king's rook, I'm going to put it in a different column, but I know that it's on this 0th rank, and I know it's white, and so on and so on. Let's demonstrate how this works by writing some code. So we'll demonstrate the object creation process for the chess game with C++. And here we have a method called board reset. And I'm going to allocate a new space, a new pawn, a rook, bishop, knight, and stuff like that. Okay, we need to find a better way. Okay, to do this, I'm going to create a factory. Okay, so I have my black factory and my white factory both derive off piece factory, and notice how my factory method is a pure virtual function. Now I'm also going to create a helper function that's going to create pieces when I have to specify a given row and column. This is going to happen with promotion or when with the pawns or the spaces, because there's going to be many of those. Okay, now that I've created these guys, and I have to implement my factory, so I'm going to start with my black factory. Okay, now I'm clearly complaining because I don't have my factory method implemented, so I better go implement that guy. And this is the one right here. Okay, now we have our piece factory created. The last thing we need to do is do the same for the white factory. Okay, now that all this is finished, the last step we're going to do is integrate this. So this is where I create my pieces. So now things are going to be much easier. So instead of saying new rook, I'm going to create some factories. Now I'll create my rook. So this is white pieces. So I'm going to say white factory dot factory. And this is going to be my white rook. So this is going to be my queen side. Now notice how the factory knows where it's supposed to be and what color it is based only on its color and its position. So this is going to greatly simplify my code. Now, right now, this is going to create a white bishop and queen and rook and knight. So I need to make sure to turn it to my black one. Now, the last thing I got to do is do my pawns. Now, notice how I'm not have my pawns are going to be, I have to specify the position for the pawns. And now we're finished. And notice how the reset function doesn't have to worry about the position or the color of different pieces because the factory knows about it. And the white versus black version of each of these classes knows about the differences as well, about where they're supposed to be and what color they are for the white as well as for the black. This is example 39.3 in the abstract factory section of the object creation chapter of the software design textbook.